All right, we're recording. Yeah.
For our second PA program, are we allowed to use headers, or do you want it all in one big source file?
Tell me what you mean by using headers.
I want to use a header file to store the forward declarations for my functions and a struct.
That is perfectly fine.
Okay.
Oh, I have no camera. I have an invisible hand. One of the two.
PA2 says you can find PA1 here.
Oh, yeah, my bad.
It's a different
It is not a PDF, so yeah.
My hand's not invisible anymore. Good. All right, I'll fix Canvas so it says PA2. But yeah, that is PA2 that's posted. All right, let me start by talking about ODP 409 because there was massive amounts of trouble that people had with this. And so let me run through the basic ideas here. So refresher, right? You're writing a program that takes a command line argument, and I'm not doing an attendance ping today. Everybody gets credit for attendance because it's Thursday. So you're writing a program that takes a single command line argument, right? It's a double, it's a number, and it should print the square root of it, but it's doing error checking. So what are the possible errors that you can encounter in trying to do this? You could have no argument. You could have too many arguments. So you might just say ODP, or you might say ODP 1, 2, 3, right? If you have the right number of arguments, it could be, not a double. It could be a double plus extra stuff. Or it might be, exactly one argument, which is a double, but it might be a negative number. So these are all the different errors that you can encounter. Right? If there's no argument or there's too many arguments, what does it say you should do? You should print out ERR. If it's not a double or it's a double plus extra stuff, that's invalid. If it's negative, then it's NEG. Otherwise, you can go ahead and print the square root. And this just happens to be the order in which you can write your code to do these checks. So how do we know if there's no argument? Well, if there's no argument, argc would be equal to 1. If there's too many arguments, argc would be bigger than 2. So if we want to think about this in terms of flow, right, we could do something like this. Do we have the correct number of arguments? If yes, we're going to go on. If no, then we're just going to print out error, and we're done. If you did not get assessment done by 10 o'clock, then it's closed out. And there's no option for turning it in late.
I literally missed it by 5 seconds.
That's horrible. Okay, so we can check to see if we have the correct number of arguments, and if not, we can just print out error and we're done. We can exit right there. But if we have the correct number of arguments, now we can check this stuff, right? So is this a valid double? And if it's not, then we print out the word invalid and we're done. But if it is, then we can check to see if it's negative. And if it is, we'll print out negative and we'll exit. Otherwise, we'll print the square root. All right, so there's a way to look at the flow of this, right? Okay, so how do we code this up? Check the correct number of arguments. If not, print error. If we have the correct number, we'll go on. So usually when we write an if statement, we say if some condition, and then in curly brackets we list the thing that we want to do if that condition is true, right? So this will map a little easier to see if I think about what I want to do if my statement here is a yes, right? So let me rewrite this flow chart as something like this: wrong number of arguments. And now I can say yes if you have the wrong number of arguments. Let's print out error. And let's exit. If not, then I'm going to skip the body of the if statement and go on to the next one. Well, same thing here, valid double. If it's not valid, I want to print inv. So let me change this to something where the action I want to do is in response to this condition being true. So I'm going to make this condition, do I have an invalid argument? And if it is, then I'm going to print out inv and exit. Otherwise, I'll continue. Okay, well, here I already have a condition where my yes says what I want to do. So I'm going to say, is my argument less than 0? Or is it negative, right? So is the argument negative? And if it is, then I'll print out negative. And I'll exit. Otherwise, I'll print the square root of the argument, and I'm done. All right, so this we can map into C code pretty directly, but we got to do some of these tricks that we went through yesterday with scanf and argc and so on and so forth. So first thing you got to do is check the number of arguments. And we do that by looking at argc. So assuming you've written your main program, and really there's no reason not to call these things argc and argv. They're just variable names, but really if you call them anything other than that, you're going to raise eyebrows with team members or interviewers or things like that. So argc, argv. And how do we know if we have the wrong number of arguments? Well, what's the right number of arguments here? We want to do something like ODP 409, 26.2. 1, 2. If we type something like this, argc will be equal to 2. So what's the wrong number of arguments? Argc is not equal to 2. And this is important, right? I could say, if argc is equal to 2 or if argc is equal to 1, but argc1 is not the same thing as not equal to 2. Right? Either argc is 2 or argc is not 2. So we could say, if argc is not equal to 2, print error, and then just return. Please don't send me email via Canvas. I am getting close to just shutting that email off completely because it is so problematic at times, please send me email to nmacias@clark.edu if you're trying to reach me in email. Can I check the sign of the arg and then invalid arg? No, and we'll see why in a minute. But the first thing you got to do is you got to check argc. Because invalid arg, I'm going to use scanf to do this. And what am I going to scan? I'm going to scan argv bracket 1. But if argc is only 1, argv bracket 1 will throw a seg fault if I try to look at it. We'll look at that in a minute too. But if argc is not 2, I'm going to print an error. Okay. Otherwise, I'm down here in my code now. And I want to know if my argument is valid. So I'm going to do something like, you know, integer return value equals scanf argv bracket 1 %lf %s address number comma extra. So that whole trick that we did yesterday, and we'll look at this in code in a minute, but we wrote this a bunch of times, right? So how do I know if I have an invalid argument if return is not equal to 1? And really there's only 2 cases. Return equals 1, that's valid. Return not equal to 1, that's invalid. Now, it could be that return equals 2. It could be that return equals 0. It could be that return equals -1. So I could check for all 3 of these things. I could say if return is equal to 2, or return equals 0, or return equals -1, then it's invalid. But really, all I need to do is say if return is not equal to 1. Because this is when I know it's valid, if it gives me back exactly one thing. And the negation, CSE215, if you're in there, the negation of this proposition is that return is not equal to 1. The negation of return equals 1 is not return equals 2. How many dollars do you have in your pocket? Do you have $1 in your pocket? Either you do or you don't. That's not the same as saying, you know, do you have $2 in your pocket? If you don't, you must have 1, right? So the negation of return equals 1, return is not equal to 1. So what do you check here? If return is not equal to 1, print invalid and return. Now we're down here. You've got an argument. It's a valid floating point number. Let's see if it's negative. If number is less than 0, print negative and return. Otherwise, you've made it all the way through your checks. Now you can do what you did in ODP 408, print the square root of your number. All right, so let's see what this looks like in code. And test cases, somebody asked about that. So what were the test cases? First case, so first case was a -1. Second case was just some text. Third case was a 5 followed by something that's invalid. Fourth case was an empty line, and then the fifth case was just the number 7. So those were just some test cases. All right, so here's a way to do this successfully, and this basically, you know, parallels this code that we just sketched out. If argc is not 2, print error and return. Otherwise, I'm going to do my scanf with the funky extra stuff, and I'm going to save the result from scanf in flag. If flag is not 1, it's invalid. Otherwise, I'm going to check the number that we converted, which is x, and if it's less than 0, I'm going to print negative. Otherwise, I'll find the square root, and I'll go ahead and print that out. So if you, and don't forget your -lm when you link. So if you run this, right, without any arguments, it's invalid. If you run it with multiple arguments, it's invalid. It's an error. If you run it with exactly one argument, it'll print the square root. If it's got extra stuff after it, if it's just gibberish like that, it's invalid. But you know, if it's got the wrong number of arguments, that's an error. And if it's a negative number, that's negative. Otherwise, it prints the square root. And so what can happen, right? Suppose that I do this. Let me just space these out a little. Right? Suppose I do things like this. And this is something that I saw in a lot of code, right? What's going to happen here? Well, if I do S123, that's fine. If I do S1 this, that's fine. But if I just do S1, I get a seg fault. Okay, why am I getting a seg fault when I just do S1? What's causing the seg fault here?
You need to check argc first.
Yeah, what happens if I don't?
You get the seg fault.
Yeah, where's it coming from?
It's trying to access memory it doesn't have permission to access.
Yeah,
Scanf.
it's happening right here in the scanf. It's trying to access this element of the array, and there is no element 1 in the array. Since I only typed one thing on the command line, just, you know, S1, my array contains a single thing, and that's in argv bracket 0. So argv bracket 1, that is not an accessible memory location, and that's what a seg fault's telling you usually. You're trying to access memory that you don't have permission for. So I can't even do this scanf unless I first know that argc is you know, equal to 2. So this has really, really, really got to go first. All right, and then if argc is 2, I know that this is accessible. I won't get a seg fault, and I know I've got exactly one argument, right? And so I can go on. Why are we checking for argc? Not true, because if that's true, then it runs error. Yeah, so let's look at some cases. Right? So in this case, argc is equal to 1. In this case, it's 2. In this case, it's 2. In these cases, it's 3. It's always just the number of things in the command line. If I try to run my program like this, that's an immediate error. That's ERR. If I try to run my program like these, that's an immediate error, ERR. So I don't even want to continue checking unless I know I've got a case like this. And so that's why I'm insisting that argc be equal to 2. But, you know, once I do that and I know that argc is 2, now I got to say, hey, do I have a number or do I have something like ha? So that's what that next check is doing, right? That's why we're checking the return value from scanf. And the way to tell that you converted a double and not an extra is to see if this is equal to 1. Because the return from scanf is the number of things it converted. What we're hoping is it converts one thing. That's the %lf going into x. That's the double. So flag's not 1. We're going to go ahead and do that. Now what happens if I do something like this? If I check to see if x is less than 0 before I check the result of the flag. So I'm lucking out here, right? It's telling me this is invalid. But if I do this enough times, once in a while, it's actually going to come back and say negative. Because if I don't succeed in converting, if I have something that's not a valid double, x is not going to get changed, and since I didn't initialize x, the check here is going to be whatever random value happens to be in that location in memory. And for example, if I, oh, network's getting bad. Oh boy. Right? I mean, if x happens to start off life with a value of something less than 0, right, I should be saying this is invalid, but instead I'm saying it's negative, right? And the reason is that you got to make sure that your scanf gave you something meaningful before you check the result that scanf gave you. So check to see if it succeeded in converting something. If it didn't, stop right there, just say invalid. But then, you know, if it did give you something meaningful, if it said, yeah, I do have a valid argument, now you can check to see if it's negative. So if you do that check second, right, it'll correctly say it's invalid. And then you can go ahead and you can say, okay, I have an argument. It does convert as a double. Now you can say, is that double negative? And then if you get through all of that and it's not negative, now you can go ahead and say, okay, I'm going to take the square root and print it out. See, I check the number of arguments, and then the sign, and then invalid or valid. That's what I have to show. Yep, exactly. Yeah, so someone posted a good example in chat there of can you go back to the paper about argc? So this one, so argc, just count the number of things separated by spaces. Welcome. And then since we're here, remember, you know, these things get loaded into our argv array, starting with element 0. And the trick, which you can, you know, figure out with a test case, or you can put in your notes, or you can just remember, is if argc is 3, then we are allowed to go up to and including argv bracket 2. If argc is n, you can go up to argv n minus 1. And that's always how arrays work with you know, languages that start at 0. So if you have an array of 10 integers, you can go from x0 through x9. And x10 will probably give you a seg fault. All right, so let's talk about PA2. So this is posted on Canvas. Let me pull it up from Canvas. Speedy Canvas. Let me go ahead and fix my typo while we're here. All right. So PA2 is another version of the stick picking game, but this is written in C. And the basic structure for the game is the same as what you did in PA1. So the same algorithm for picking sticks, take the number of sticks mod 4, set it to 1 if it's 0. All of that stuff is the same. But there's a number of differences from PA1, and these differences are worth points, okay? So major differences. First of all, your program's got to be written in C, not Bash. Okay, otherwise, it's just PA1. The executable must be named stick. Okay, so compile your program, make the executable named stick. The computer always goes first, so don't ask who should go first. Always give the first turn to the computer. And then a big one, assume the user may behave badly. So they might enter anything at any time, and your program's got to handle unexpected input. If you want to know how many sticks do you take and they say ha ha, you've got to deal with that. If they say I want to take 5 sticks, I want to take negative 12 sticks, I want to take 2 space 3 space 4 sticks, you got to deal with all those situations. So this is this idea of input cleansing, right? Assuming that the user is a cat and it thinks it's chasing an invisible mouse across your keyboard, right? You got to be prepared for whatever kind of input the user specifies, and you've got to do something reasonable in response to it. You can't just, if they say blah blah blah, treat that as 1 or something, right? You gotta insist that input be properly entered, or you've got to, say this is not proper, try again. All right. In the beginning of the game, the user will specify how many sticks to play with, but there's 2 ways you can do this, right? One way is to just say stick and hit enter, and the game says how many sticks you want to play with, and the person says 25 and hits enter, and you play with 25 sticks. The other option, though, is a command line argument. If you don't want to have to do this dialogue, you can just say stick space 25, and the game immediately starts off playing with 25 sticks. Is that clear? So 2 ways to specify the number of sticks, either as a runtime input or as a command line argument. And you got to handle both of those. You don't get to choose which one to do. You got to handle them both.
The command line one would suppose that the player already knows what they're supposed to do, right?
Right. So this is for like the expert player who just wants to run quickly into the game. Yep.
Just plug in the number.
Exactly.
Do both if you wanted to, right?
You have to do both. Yeah, I mean you have to implement both in your game. I'm going to repost this and make that clear. You don't get to choose which one of these to do. Your program has to work with both of these.
Okay.
All right. So if a command line argument is given, it's got to be a single command line argument. So if they say stick space 25 space hello, right, that's an error. If they say stick space hello, that's an error. Or if they say stick, hit enter, and it says how many sticks do you want to play with, and they say hello, or 25 space hello, or 25.2, those are all errors. And unlike PA1, if there's any error in specifying the number of sticks, you exit immediately. Print a message and exit. Okay, your number of sticks has to be at least 20. 20 is legal. Anything bigger than 20 is legal. Anything smaller than 20 is not legal.
Because there's data types in C, is it fine if I max them out at like 32,500 so I can just use integers?
You can use integers. Integers will go up to 2 billion, and you don't need to check for that. If they type in 3 billion, just let it do whatever it does. I won't try to play with 2 billion sticks. But don't max it out at 32,000 because integers can go up to 2 billion.
Really?
Yeah, so integers are On a modern system, they're usually 32 bits. So it goes from minus 2 billion to 2 billion, 2 to the 31st. If you have like an Arduino or something, those will max out at 2 to the 15th.
Okay.
2 to the 16th minus 1. Yeah, 2 billion would like kill my whole weekend. All right, so lots of things to check for, right? But it's basically, you know, the same kinds of things that you're doing in the last two ODPs, well, in ODP 409 in particular, right? You're checking, you know, that there's exactly one argument and that it's a valid number, meaning it's an integer exactly and it's bigger than or equal to 20, right? Or if they specify an input value, which you're going to get with fgets, which we'll talk more about today or Monday. You run it through scanf, make sure it's a valid integer and it's at least 20. And if anything goes wrong with that invalid entry, number smaller than 20, anything at all, print a message, say goodbye, and exit. Right, you're done. Don't keep asking them how many sticks. All right. Assuming a valid number of sticks was specified, then you start playing the game just like in PA1, except the computer goes first. And there's one other big difference here, which is when you ask the user how many sticks they want, they can try to answer that as many times as it takes. Don't give up after 2 tries, right? So if they just hit enter, that's an invalid response. Ask them to enter 1, 2, or 3. If they type something bigger than 3 or less than 1, that's an invalid response. If they type, 2 followed by some other stuff, that's an invalid response. If they type a 2 and a space and something else, that's an invalid response. Right? So any kind of invalid response, ask them to try again and keep trying until they put in a correct answer. All right, and this is where you're going to have to use fgets and scanf. Don't try to use ASCII to integer because it doesn't do error checking. Right? And if they type something like, space 3 or 001, those things are valid. So your error checking is basically, does scanf see this as exactly a %d? So do what we did in 409, but look for an integer %d followed by extra stuff. All right. Make sure your stick program is executable. Make sure you include the source code in your repository. Your CSE224 repo should have a subdirectory named uppercase PA2. And in that directory, you should have your source code and your executable stick. And just push those over to your GitLab repo before the deadline. Make sure your code runs on the Linux server. If you're developing on some other environment, copy your code over to the Linux server and make sure it runs there, because that's where I'm going to test it. And if you're working in some other environment and it's got some flag set up that makes your code work even though there's errors in it, you might not notice that unless you test it on the Linux machine. So test it on Linux, engrcs.com. All right, and that's pretty much it. It's a one page write-up. So any questions about that?
Not yet.
Okay. All right. Let's talk more about fgets. So let's play with some junk code, right? So I'm gonna do fgets temp, and let's suppose we want to get from the user an integer while our program's running. So I'm gonna say something like this: enter a number. And then I'm going to say fgets temp 120 standard in. And then I'm going to do an scanf on that. Alright, so I got an integer number, I've got a character temp, I'm going to say enter a number, I'll do an fgets, which reads from the user, right, while the program's running, and then I'll take whatever they typed in, and scanf it with a %d, save the result in num, and then print out that number. It's definitely typo o'clock. Okay, so I'll say try 2 and I'll type in a number and I'll say 256, and it says your number is 256. And this works for negative numbers as well. But if you type in something that's not a number, you get who knows what, right? So how can we tell if they typed in a valid number or not? We check the return value from scanf. Alright, so again, I'm going to check to see if return is equal to 1, not equal to 0 or 2 or something else. Say if return is equal to 1, I'm guaranteed that this thing found an integer and saved the result in num. Any other condition, else I'm just going to print out an error message. So if I type a good number, that's fine. If I type something that's not a number, it'll tell me. And then we have the same condition that we were talking about yesterday, is if I have extra stuff after here, scanf will still convert what it can into an integer. So to pick that up, we're going to do exactly the same trick that we did yesterday, which is make yourself space for some extra stuff. Add a %s after the thing that you actually care about, and try to scan into that extra stuff. And so now it will notice that there's extra stuff at the end and pick it up accordingly. Alright, so this makes sense, assuming that 409, ODP 409 made sense. Does this seem like, you know, sort of the same thing?
Yep.
Okay.
So you said that it still grabs the number even when it like quote unquote fails. Does that mean that?
So can you back up again, because your audio freaked out on me. Can you start over again?
Yeah, your audio is not.
Oh, sorry, I don't have my usual microphone with me.
That's okay. You're good now.
You said that it grabs the integer even like just regardless. Are we then just adding the additional like %s so that way it does it all properly and returns a 1?
So if we say 1, 2, 3 ABC and we just scan with %d, the 1, 2, 3 will go into num. But and this will return a 1. But we don't know if there was extra stuff after there. So the %s is saying, hey, and if you see anything after the integer, go ahead and store that in extra. And if it does that, return will actually be equal to 2. And that'll tell us that something went wrong. And so we can for debugging, let's just print out what the value of return is. So if I put in an integer, it returns a 1. If I put in some extra stuff at the end, it returns a 2. If I don't have an integer in the beginning, it returns a 0. If I just hit an enter, it returns a -1. If I put extra stuff after a space, it returns a 2. And so the only time I know I've got a valid number is when return is 1. So that's just kind of a convenient trick we can use to know if we got good input. All right, let's talk about scanf versus scanf. Let me make an infinite loop here. All right, so I'm going to do some input in a loop here. And I'm going to say enter a number, and I'll do an fgets, and I'll convert it to an integer, num. And if I get any problem from scanf, I'll say that's an input error, please try again. Otherwise, I'll say, you know, num is a good number. Its square is, and I'll print out the square of it. So here's a handy little program. If you want to square numbers all day long, you can do it with this. So I can run try 3, and it says enter a number 4. Hey, the square is 16. Enter a number -2. Hey, the square is 4. Enter a number, ha ha. That's an input error. Please try again. And enter a number, and I'll do 2.3, and that's an input error. Please try again. So I'll do 3. Square of 3 is 9. Good stuff, right? All right, so let me break this. Let me make a version of this that instead of using fgets and scanf, just uses scanf. All right, so I'm going to say enter a number. I'll let the person type in a number, and I'll use scanf to read that number, and I'll save the return value. If it's not 1, I'll say input error. Otherwise, I'll say it's a good number, and I'll print out the square. All right. So let's go ahead and run that. So try 4. I'll enter a number 5. Hey, that's good. -1. Hey, that's a good number. The square is 25. Ha ha. Bang. Right? And so if I get this while I'm playing your stick game, your grade just dropped, about 20 points. And fundamentally this code does not seem terribly different from this code. But this is kind of inherent in the nature of scanf. And it goes to this idea of ingesting and parsing. And scanf does both of those together. It does an ingest and a parse in a single call. Well, the way scanf is written, if it doesn't find an integer in the beginning of the input, it stops. It returns, a 0 or a -1 maybe, and it does not absorb any characters. It doesn't ingest any characters. and it says input error, try again, and I come back to scanf again, and what does it do? It tries scanning the same thing that it tried last time. And it says, oh, haha is not a valid integer. Try again. And it goes back up here, and scanf says, okay, let's see, what's our input? Haha. Oh, nope, that's not a valid integer. Right? And so we can avoid that by doing this. Use fgets, which it doesn't matter what the input is, it'll always read it and put it into memory. And the next time we call fgets, it will read a new line from input. But scanf, each time that we call it, if the thing does not begin with an integer, it just keeps rereading that same set of characters. And you end up with this kind of horrifying behavior of infinite loops. The other reason it's really useful to do an fgets followed by an sscanf is that sometimes we're not just looking for an integer. Sometimes if the user types an integer, that's valid. Or if they type an uppercase Q, that might be valid. Or if they type a lowercase I followed by an integer, that's valid. In other words, there may be more complex parsing to do. And like this, we can say, okay, let me take the line the user typed and store it in memory. That's this variable called temp. And now I can start parsing it a bunch of different ways. I can say, is it an integer? Is it an uppercase Q? Is it an I followed by an integer? And I can keep analyzing it 100 different ways without actually reading in more stuff from the user. Right? I read it once, I store it in memory, and then I can analyze this with a bunch of code. And then and only then when I'm ready to read a new line of input from the user do I say fgets again. If I just use scanf, I can't separate those out. Every time I do scanf, it also basically does something like an fgets. It pulls in more characters. So really, just avoid scanf completely. Don't use it. Don't even think about it. Forget that it exists, and just stick with fgets and sscanf, and you'll save yourself a lot of difficulties. So questions about that? All right.
So you didn't.
Yeah.
You didn't use extra in the code, but in actual implementation, we'll use that for the %s, right?
So yeah, normally you're going to want to do a %s and throw that into extra. And I could have done that in here too. It wouldn't change the moral of the story though. But yeah, generally you want to do a %s, pick the extra stuff, throw it into here, and then make sure that in this case return is 1.
Alright, I missed it. You put that in there. Alright, that makes sense.
Okay, cool. fgets is just a way to read input from the user, and that's all it does. sscanf is a way to parse a string, and that's all that it does. But scanf is doing both of those. It's reading input, and then it's parsing it. And so the whole goal here is let's just split those out. Let's first do an input, and then let's do a parse. So we're just breaking scanf into 2 separate pieces. Because sometimes we want to do input, sometimes we want to do parse. We might want to parse 5 different ways after we've done input. So that's why we're breaking this up here. All right, we are out of time. I got to get to my next class. Remember, no classes on Friday. This week it's a student holiday, so I will see you on Monday. I will have office hours in the morning. I took it off the calendar for advising, but I will have office hours at 8:30 as usual if anybody wants to come in. Otherwise, have a good weekend. I'll see you next week.